This is the setup video for section 5.1, problem number 7. All right, it says a small island 2 miles from the nearest point P on a straight shoreline of large lake. If a woman on the island can row a boat at 3 miles per hour and can walk 4 miles per hour, where should the boat be landed in order to arrive at a town 10 miles downshore from point P in the least time? All right, so I gave you this picture. All right, so remember, if she were to go from the island directly to the shore, right, that would be to P, that would be 2 miles. All right, but now what we're going to do is we're going to say, well, she's going to row to somewhere on the shoreline here, X miles from point P. So if she's going X miles from point P, how far has she actually traveled over the water? Well, this is a right triangle, of course, and so we can use Pythagorean theorem. So the hypotenuse would be the square root of 2 squared plus x squared, or 4 plus x squared. All right, so that would be the distance over the water. Then once she gets to this point, then she's going to travel 10 minus x to the town. Well, remember, the total distance from point P to the town is 10 miles, and so if she rows to a point x miles from P, then she has 10 minus x remaining. All right, so now what we want to think about is where should the boat be landed in order to arrive in the town in the least time? So we need to think about time. So how am I going to get time from what I have over here? Well, remember, these things like 2 miles, root 4 plus x squared, 10 minus x, those are all distances, right? So how am I going to figure out time given a distance? Well, remember, we were also given the rate at which she travels. So she can row 3 miles per hour and walk 4 miles per hour. All right, so I want to think, okay? You should know that a rate is equal to a distance divided by a time, right? So like rate is like miles per hour. So if I wanted to solve for time, I'm going to multiply by t and divide by r. So t is actually equal to the distance divided by the rate. All right, so the total time is going to be what? The time over water, or time rowing, plus the time walking. All right, so what is the time spent rowing? Well, it's going to be the distance rowing, which is the square root of 4 plus x squared, divided by the rate at which she can row, which is 3 miles per hour. So this is really like 1/3 times the square root of 4 plus x squared. Then plus the time spent walking. So we're going to take the distance spent walking, which would be 10 minus x miles, divided by the rate at which she can walk, which is 4. So really, this is like 1/4 times the quantity 10 minus x, or you could say 10/4 minus 1/4 x. All right, and so now this is the function for time that we wish to minimize, right? Least time.